Mrs. Post asked, how would you find the permutations for the sums of specific numbers? And so what we're going to do is we're going to look at the permutations for the sums of 1 and the sums of 2, the sums of 3 and the sums of 4, and the sums of 5 and the sums of 6. How many different sums can we get for each of these particular numbers? And how would we work that with the kids so that it's fun and it's enjoyable and they can start to see what's going on? Rather than use these specific unit blocks, we're going to actually use the green ones to start off to give you an idea. So if this was our 1, well, that's obviously the same thing. If that's our number, which is 2, we could use 2 green unit blocks. 3, we would use 3 green unit blocks, and then so on for 4, and then for 5. And then for 6, we would have 6 green unit blocks. So the objects in this particular case are going to be the ones. So for the sums of the number 1, we just have 1 1. For the sums of the number 2, we'll be using 2 1s. The sums for the number 3, we have 3 1s in it. The sums for the number 4, 4 1s. The sums for the number 5, 5 1s. The sums for the number 6, 6 1s. So I'm just going to move these out of the way for a moment because we don't need them all in our picture. And what we're going to do is we're going to look at this particular one. Now, what we're looking for is the number of spaces that we can create between the blocks. And if we're using just the number 1, we can't create any spaces between the blocks. So there are 0 spaces between the blocks. Now, let's put that there. If we look at the number 2, how many possible spaces are there? Well, there's 1 possible space between those 2 blocks. Now, for each space that you have between a block, you have a choice. You can either use the space or you can not use the space and keep the blocks together. So can you see that? You have a choice. There's this 1 space, so 1 possible space, 2 possible choices. In the number 3, you've got 3 possible spaces, and you have 2 possible choices in each space. Either keep the spaces there, like use the space, or don't use the space. If you don't use the space, then the blocks end up like this. Okay? Again, for the number 4, you can see that there's 3 possible spaces, 2 possible choices for each space. The number 5, 4 possible spaces, 1, 2, 3, 4, and 2 choices, either use the space or don't use the space. Okay, and then again for the number 6, you've got 5 possible spaces, 1, 2, 3, 4, 5. So you can either use the space or don't use the space. We're not going to have it where there's no spaces at all. So there's no space here, so there is no sum. There's no, if we keep this like this, there's no spaces, there's no sum. No spaces, no sum. No spaces, no sum. No spaces, no sum. No spaces, no sums. Okay, so if we look at the possible spaces for 2, the number 2, and we're going to use n as our number. So in this case, n equals 1. In this case, n equals 2. And then so on, n would be equal to 3. Okay? All right. So for n equals 2, we have a possible space of 1 possible space. We can either use it or not use it. So if we're looking for the total amount of sums that we're able to use for the number 2, in this particular case, there is really just 1 sum, and that's 1 plus 1. Start here is make 2 groups. So we use that space and then push those together. Do you see you've got 2 groups, 2 add-ins? So 1 plus 2. And then if we push that over there, then we've got 2 plus 1, 2 groups, 1 space. And then we try to do 3 groups once we've used all the 2 groups up. And so then we'd have 1 plus 1 plus 1. So then if we do 4, we've got the possibility of 4 spaces. And again, each time you have a space, you have 2 choices. You have the choice to use the space or to not use the space and push the ones together. So first of all, we want to try and make 2 groups. So we can do this. So if we do 2 groups, we've got that space there, then we would push these together. So 1 plus 3. Then if we decided that we were going to not use that space and use that space, we'd have 2 plus 2. And then if we decided to not use that space, we'd have 3 plus 1. And that would be all the groups of 2 that you can make. Can you see that here we use that space, then we use that space, then we use that space. So there's 1, 2, 3 groups of 2. And I don't know if you notice it, but the spaces correlate to the plus sign. So when you've got 3 plus 1, there's your plus sign. And there's your one addend 3, and there's your other addend 1. Okay? So then we would space them back out. And so we did 2 groups, or 2 addends. Now let's try and do, I hope everything is in there, that you can see that in my window here. Maybe I should move that slightly. So now we're going to try 3 groups. So we've got 3 spaces and 4 groups, but we want to try for 3 groups. So let's use that space and then close that space down. Well, we end up with 1 plus 2. Okay, so now maybe we want to use that space, not that space, and use that space. Well, 1 plus 2 plus 1. Well, now maybe we want to shut that space down, use that space, and use that space, and we have 2 plus 1 plus 1. Are you kind of starting to see what we're doing here? Now we can do this for every single number up to 6. You could carry on after that, but I've done it up to 6. Now what I've done is I've used the unit blocks now in order to show the different addends. So for the number 2, for n equals 2, well, for n equals 1, we've got 1. For n equals 2, and now I'm going to erase these because I think you have an idea of what I'm talking about, how you're getting your different sums. So now for n equals 2, I'm going to, this is actually the only option we have. Now what I've done is I've pushed these, I'm going to leave them slightly apart so that there is a space. But can you see how that's 1 plus 1? And then for 3, we ended up with these addends. So for 2 groups, we've got that, and we've got that. Now, can you see how that was just 2 1s on top there? And that was just 2 1s there. But what now I've done is substituted in the unit blocks because they're a little bit easier to deal with. Plus, not everybody's going to have enough 1s to do this otherwise. And then, so that's the only way I can do 2 groups. And so then I'm going to do 3 groups. Well, there's my 3 groups. Okay, is there any other way to make it? No. So then we do 4. Well, here's my 2 groups. And if I were to put my spaces in them, we could do it like this. And we could actually do this. Then you can see. There's some spaces there, some spaces there. And this would be n equals 4. There's my 2 groups. Now I can't do any more for 2 groups. So then and this will take some exploration with the kids to see that. Now I've got 3 groups. 3 groups, 2 spaces. And then I do 4 groups, and I can't do any more than 4 groups with this. So each of these lines, now what I'm going to do is, instead of having these spaces here, is just put them like this. So 1 plus 1, Okay, 1 plus 2, 2 plus 1, 1 plus 1 plus 1 plus 1. So what I've done here is this is the top one is, this one has no spaces. This has 2 spaces or 2 groups, 2 groups, 3 groups, 2 groups, 3 groups, 4 groups. Okay, and then n equals 5. N equals 5. Let's start off with our 2 groups. So 1 plus 4, 4 plus 1, 2 plus 3, 3 plus 2. Over here it's 2 plus 2, 1 plus 3, 3 plus 1. Down here there's 3 groups, so 1 plus 1 plus 2, 1 plus 2 plus 1, 2 plus 1 plus 1. This is 4 groups, 1 plus 1 plus 1 plus 1. This is 2 groups, 1 plus 3, 3 plus, or sorry, 1 plus 2, 2 plus 1. This would be 3 groups, 1 plus 1 plus 1. This is 2 groups, 1 plus 1. This is 0 groups. These are all the groups I can make for n equals 5 that have 2, or sorry, this is the only ones that I can make for 2 groups for n equals 5. For 3 groups, I can make this many. So 1 plus 1 plus 3, 1 plus 2, or sorry, 1 plus 3 plus 1, 3 plus 1 plus 1, 1 plus 2 plus 2, 2 plus 2 plus 1, 2 plus 1 plus 2. And then that's as many groups of 3 as I can make, and these are groups of 4. So 1 plus 1 plus 1 plus 2, 1 plus 1 plus 2 plus 1, 1 plus 2 plus 1 plus 1, 2 plus 1 plus 1 plus 1. And that's all the groups of 4. So now I'm on to groups of 5. 1 plus 1 plus 1 plus 1 plus 1. So the spaces now, I don't know if you've noticed, but I've replaced them with plus signs, or the word plus. And then if we do, hopefully, actually, I wonder if I should move these over, if these will fit. So for n equals 6, hopefully you can see this. I'll find out in a minute. N equals 6. Groups of 2. Can you see that there's a space there and there's 2 groups? And then there's a space there, 2 groups, space, 2 groups, space, 2 groups, space, 2 groups. Okay, so 1 plus 5, 5 plus 1, 2 plus 3, or sorry, 2 plus 4, 4 plus 2, 3 plus 3. Just want to check that you can see all of this in there. Okay, so that's as many groups as I can make, as many 2 groups that I can make, and now I'm making 3 groups. So 1 plus 2 plus 3, 1 plus 3 plus 2, 2 plus 1 plus 3, 2 plus 3 plus 1, 3 plus 2 plus 1, 3 plus 1 plus 2, 1 plus 1 plus 4, 4 plus 1 plus 1, 1 plus 4 plus 1, 2 plus 2 plus 2. That's as many as I can make with 3 groups. Then I'm on to 4 groups. I did this ahead of time. I'm pretty sure you can tell that. So there we go. I think I'm going to have to move this up slightly so you can see all of them. Hopefully this will fit. So now can you see that there's 4 spaces here and 4 groups? 4 spaces, 4 groups on each one. Okay, then we go over here. Hopefully this can fit in. Let me see. Are we able to see that? I might need to put that up some. Okay, so n equals 6. These are 5 groups. 1, 2, 3, 4, 5. Can you see 4 spaces, 5 groups? 1, 2, 3, 4 spaces, 5 groups. 1 plus 1 plus 1 plus 1 plus 2. 1 plus 1 plus 1 plus 2 plus 1. 1 plus 1 plus 2 plus 1 plus 1. 1 plus 2 plus 1 plus 1 plus 1. 2 plus 1 plus 1 plus 1 plus 1. And then the last one would be 6 groups. Now this is going to probably take some work for the kids to get to this you know, for n equals 6. This would take a bit of work. But this is 1, 2, 3, 4, 5 spaces, 6 groups. 1, 2, 3, 4, 5, 6 groups. 1 plus 1 plus 1 plus 1 plus 1 plus 1. And that is all that you can make with that. Now, let's look at what we would do if we had more, like n equals 7. And I don't think you can see that there perhaps you can. Let's put that there. N equals 7. Okay, we don't know what that is. N equals 8, N equals 9. So the sum's for 7, the sum's for 8, the sum's for 9, and so on, right? Well, if you look at this, there's, in this particular one, there are 0 spaces, okay? And for this particular one, the most spaces that you can have is 1 space. And the most spaces here that you can have is 2 spaces. And here is 3 spaces, here is 4 spaces, and here is 5 spaces. And if you get out if you just use these, you can see there's 0 spaces, there's 2, there's 1 space, there's 3, there's 1, 2 spaces, right? Here is the number 4, and there's 3 spaces. There's the number 5, and there's 4 spaces. There's the number 6, and there's 5 spaces. Now, I don't know if you noticed, but the spaces are the same as n minus 1. So n here is 1, 1 minus 1 is 0. N is 2 here, 2 minus 1 is 1. N is 3 here, 3 minus 1 is 2. 4 minus 1 is 3, 5 minus 1 is 4, 6 minus 1 is 5, and so on and so on. I'm going to push that up a little higher. Okay. So for this, there is, what am I thinking here? I actually took some notes so I wouldn't forget. For this, it is, let's start over here because I've lost my train of thought. In this particular one with 6, you have 5 spaces, right? 5 spaces. And 2 choices in each space. Okay? So there's 1 space, you have 2 choices. You can either keep the space or push the blocks together. For the next space, you still have 2 choices. That space, 2 choices. This space, 2 choices. This space, 2 choices. Okay, can you see that that is 2 to the power of 5? And we have to subtract 1 because we are eliminating the option of having no spaces. Okay, so if you look at 2 to the power of 5, isn't that really n minus 1? 6 minus 1, right? Isn't that the number minus 1? And couldn't we rewrite that as 2n minus 1? Okay, so if we put 2n minus 1 minus the 1 because we don't want to have no spaces, okay, then it would be 2, and n is 6 minus 1 minus 1, 2 to the power of 5 minus 1, 2 to the power of 5 is 32. 2 to the power of 5 is 32. 32 minus 1 is 31. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm missing one here. Oh, 31. I stole that. So 31. Okay? 31 possible permutations for the sums, for the sums or the sum of 6. Okay, so then let's look at, so can you see that, what I did there, hopefully? I hope that makes sense to you, and I hope that you can see everything on the board. Okay, so then let's look at, this one. There's the number 5. We have 4 possible spaces, which really is just n minus 1 spaces, right? Okay, and for each of those spaces we have 2 choices, so 2 times 2 times 2 times 2, which is really 2 to the power of 4 right? Minus 1. Or we could write this as 2 to the power of 5 minus 1, which is really n minus 1, right? And if we substitute that in, 2 to the power of 5 minus 1 is 2 to the power of 4 minus 1, which is 16 minus 1, which is 15 possible permutations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possible permutations. So let's do that for n equals 4. So 2 to the power of n minus 1, right? And the reason it is that is because there is 4 minus 1 spaces, right? And in each particular one, we have 2 choices. So 2 times 2 times 2 minus the 1 for the no spaces, right? Which is really 2 to the power of n minus 1, which is 2 to the power of 4 minus 1, which is 2 to the power of 3 minus 1, which is 8 minus 1, which is 7. 1, 2, 3, 4, 5, 6, 7. Are you seeing the pattern here? Okay, so for this one, 2 to the power of n minus 1 is minus 1 is 2 to the power of 3 minus 1, 2 to the power of 2 minus 1, which is 4 minus 1. I'm not sure why I wrote. What did I write here? 0, 1. Oh, those were the spaces. Those were the spaces. So here there was 15 permutations. Here there was 31 permutations. Here there was 7. 4 minus 1 is 3. You're going to have 3 permutations. If we do again 2n minus 1 here, minus 1, we've got 2 to the power of 2 minus 1, which is 2 to the power of 1 minus 1, which is 2 minus 1, which is just 1. And then if we do this, 2 to the power of n minus 1 is 2 to the power of 1 minus 1, 2 to the power of 0 minus 1, 2 to the power of 0 is 1 minus 1, which is 0. Can you see that? So then, if you wanted to find how many permutations there were for n equals 7 without having to build all of these, then you would go 2 to the power of n minus 1, so 2 to the power of 7 minus 1, 2 to the power of 6 minus 1, which is really 2 times 2 times 2 times 2 times 2 times 2, which would be 32 times 2 is 64, minus 1 is 63. Now, I don't know if you noticed, but these are all odd numbers as far as the permutations go. So n equals 7 is 63 permutations, which, if you look at it, is 31 plus 2 to the power of 2 to the power of 4. 2 times 2 times 2. Did I do that right? 2 to the power of 4. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. 2 to the power of 5. So if you add 2 to the power of 5 to this, you'll get the next one. If you add 2 to the power of 4 to this, you'll get this. If you add 2 to the power of 3 to this, you'll get this. 2 to the power of 2 to this, you get this. 2 to the power of 1 to this, you get this. 2 to the power of 0 to this, you get this. There's a lot of patterns that are going on in here. So basically, though, how you want to start this with the kids is really simple. You don't need to necessarily just use the 1 blocks. You could simply say, okay, well, we want to find how many different ways are there to make the sum of 4, which is the question that Mrs. Post had asked me. So how many different ways can we make 4 with the blocks? And we first want to start with groups of 2. So, well, let's see, we could do 2 and a 2, 1 and a 2, or sorry, 1 and a 3, a 3 and a 1. Okay, there's all of our groups of 2. There's no other ways to build it. And you could ask them to try it out. Is there any other ways to make it where there's two blocks in our 4? And keep in mind, this is just add-ins and plus signs. And in the other way I was showing you, it was ones and spaces. Okay, the ones, if they're pushed together, make your add-in. So in this particular case, you would have the possibility of 4 spaces, and in this particular case, you shut down that space, and you shut down that space, and you kept that space. Okay, for this one, you had 4 possible spaces, and we chose to keep that space and shut that space down. Here again, we had 4 possible choices, and we chose to shut this space down and this space down and keep that space. So we're looking for 2 groups in the first thing, which means 1 space. In the second part, we were looking for 3 groups. So that means that we have to shut down one of the spaces in order to have 3 groups. So here we kept that space, and then we shut this space down. Now we have 2 spaces but 3 groups. Here we did this. We kept that space, we shut that space down to make the 2, and we kept that space. Here we shut that space down, we kept that space and that space to get the 2, the 1, and the 1. And then here, now we had 3 groups, now we have 4 groups, we're going to have 3 spaces. Well, that's obvious, 1 plus 1 plus 1 plus 1. Okay, so how can you tell if you're finished? We'll start with 2 groups, then do 3 groups, then do 4 groups. Well, can you make 5 groups? No. Right? So that's how you can tell if you have all the permutations for 4. In this case, we have 1, 2, 3, 4, 5, 6, 7 different arrangements for the sum of 4. We can apply this strategy using ones to our unit blocks. Let me just move these over here. So if we're looking at the number 4, we could say, well, we want to start off with 2 groups, 1 space, and 2 groups. So we could start off with a 1 and a 3. Do you see how there's 1 space, 2 groups? And then we could do a 3 and a 1. Do you see? 1 space, 2 groups. We could do a 2 and a 2. 1 space, 2 groups. Are there any other ways to make 4 with 1 space and 2 groups? There's not. So then what we do is we go up 1 space, 2 spaces, 3 groups. Again, you're going to have 1 less space than you have groups, or 1 more group than you have spaces. So then we could do 3 groups, 2 spaces, or 2 spaces, 3 groups. There's 1, 2, 3 groups, 2 spaces. There is another one. We've got 2 spaces, 3 groups. Here's another one, 2 spaces, 3 groups. Is there any other ways to make a 4 with 2 spaces, 3 groups? I can't think of any other ways. I believe that we have them all. I might actually just rearrange this so that you can see we've got the 2 1s on the end, we've got the 2 1s together on the ends, got the 2 in the middle, we've got the 2s on the ends. If you look here, you've got the 1s on the ends, you've got the 3s on the ends. You can't put the 3s in the middle with this grouping, with 1 space, 2 groups. So it looks like for this, 2 spaces, 3 groups that we're done. So then the next thing that we're going to look at is 3 spaces and 4 groups. And there's only one possibility with that, and that is this. So we have 3 spaces, 4 groups. So we put them together like that. Keep in mind, we're just putting them together so that we can see they're the same as the 4, but technically we can assume that when we have this color and this color, that there's a space there, or each separate block beside another block represents a space. So for here, even though they're both green, we have a space there and then a space there. And even though all 4 of these are green, every separate block has a space between them and the next block. Okay, so with the kids, what we're looking for really is not so much spaces, but plus signs, add-ins, which would be the groups, and plus signs, which would be the spaces. So for this would be 1 plus 3, 3 plus 1, 2 plus 2, and then you've got 2 plus 1 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2, and 1 plus 1 plus 1 plus 1. So when they're doing it with the colored blocks versus just the green units, you're really looking at add-ins and plus signs rather than just spaces and groups. Although, if you wanted to, you could put them out in spaces and groups so that they could see that. So do you need to introduce them to this approach by using the ones only? No, you don't even need to bring the ones into it to teach them this way. I've used the ones to show you that you have spaces and groups and spaces and groups. You don't necessarily need to do that. If they're looking for all the patterns that they can make for the yellow block, which is a 4, which is the number 4, then all they really need to do is think about at the beginning 2 blocks, 2 groups, right? And then 3 groups, and then 4 groups. They don't necessarily need to think about the spaces so much, but you might want to talk about 1 and 3, or 1 plus 3, 3 plus 1, 2 plus 2, right? Because the spaces and the groups are the add-ins and the plus signs, or the plus signs and the add-ins. So how would you know that you had all of the patterns like we do on the table? How would the kids know when they were done? Well, it's really simple. It's like we talked about before. We're going to make groups, and the groups are going to be like how many blocks. So if we had 1 space and 2 groups, you're going to have 2 blocks. If you have 2 spaces and 3 groups, you're going to have 3 blocks. 3 spaces and 4 groups, 4 blocks. So the number of groups tells you how many blocks you're going to have. The maximum number of groups that you're going to have for 6 is going to be 1, 2, 3, 4, 5, 6. I'm not sure if you can see that, but you see if we put the spaces there, you're going to have 6 groups. So the maximum number of blocks that you're going to be able to use in your pattern is going to be 6 for the 6, for the number 6, 5 for the number 5, 4 for the number 4, 3 for the number 3, 2 for the number 1, and 1 for the number 1. Now, the maximum number of spaces that you have for 1 is no spaces, then 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces. So that means that we have no plus signs here. We have 1 plus sign here, 2 plus signs here, 3 plus signs here, 4 plus signs here, and 5 plus signs here. So what I did here was, for here I went to the maximum number of spaces, which is 0. So I have 0 spaces. It means that there's just going to be 1 group. And that's it right there. Now, 1 by itself is not considered a sum, so that doesn't get counted as a sum. So what we're looking at here, if we look at 6, which is a really big number, is we have all of the possible arrangements of 2 blocks. Actually, I'm not going to push that up because you might not be able to see it. Right to this here, we have 1, 2 blocks, 1, 2, 1, 2, 1, 2, 1, 2. When you've used all of the possible 2 blocks, then you try 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, 1, 2, 3. When you've sorted out that you've used all of the 3 blocks and all the different arrangements that you can make with them, then you go to 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And all the way down to, I believe here was 4. And then from here to here was 5. And then here's 6. So here we have 2 blocks. In here we have 3 blocks. And then we went to 4 blocks and then 5. Here we had 2 blocks and then 3 blocks and then 4. 2 blocks and then 3 blocks and then 2 blocks and then just 1 block. Now if we count up how many actual arrangements we had for 6, we end up with 31. I'm not going to take the time to count it because I've counted before, but we have 31. Here we have 15. Here we have 7. Here we have 3. Here we have 1, and here we have 0, because the number 1 is not considered a sum. There's no plus sign there. So there's 0 plus signs, 1 plus sign, 2, 3, 4, and 5, and so on. There's also a neat little pattern here. If you times that by 2 and add 1, you get this. So the amount of arrangements that you have in the number before, if you times it by 2 and add 1, you end up with the next amount of arrangements for the next consecutive number. So 2 times 1 plus 1, 3 times 1 plus 1, 1 times 2 plus 1, 3 times 2 plus 1, 7 times 2 plus 1, 15 times 2 plus 1. But this is really what we're looking for, is this here. So it's really easy if we punch that in. If we do this one here, when n is 1, n equals 1, we have 1 minus 1 minus 1, so that's 2 to the power of 0, which is just 1 minus 1, which is 0, and that's how you get that 0 there. So then if we have n equals 2, the number 2, n equals 2, we have 2 to the power of 2 minus 1, which is really just 2 to the power of 1, minus 1, which is just 2 minus 1, which is the same as 1. And then 2 to the power of 3, 2 to the power of n minus 1 would be 3 minus 1, which is 2 to the power of 2, which is 4, minus 1, which is 3. And we can go all the way up. Let's look at n equals 6. 2 to the power of n minus 1 is 2 to the power of 6 minus 5 minus 1, and that's 2 to the power of 2 to the power of 6 minus 1, is 2 to the power of 5 minus 1, and it's 2 times 2 times 2 times 2 times 2, which is 32, minus 1 gives you your 31. So if we don't know a number, because obviously using the blocks and trying to build these like this would be really time consuming and probably very frustrating at some point. So perhaps we want to have n equals 13. Then what we would do is go 2 to the power of n minus 1, and minus 1, which would be 2 to the power of 13 minus 1, 2 to the power of 12 minus 1, which is 4,096, minus 1, which is 4,095. So there's 4,095 different arrangements that you could do with the blocks for the number 13. Which is quite interesting if you think about it. I mean, it's not a huge number, and yet look at how many different arrangements they are. So they get exponentially bigger.